Welcome back, and thank you very much for all the very kind comments over the Barometric Prognosticator 2 weather machine, nautical weather machine. Most kind, greatly appreciated. Really does motivate me to do all sorts of other exciting things. Thank you. It's time of that year again. Spring cleaning done. The reciprocating chronometer. Oh, how we love visiting it. I don't know what video this is, what stage. It started off with a really nice idea, thinking, why not use zoink, a clock movement, a standard clock movement, but very good quality. I found, learnt by trial and error and advice, that Youngtown, just for your advice, Youngtown manufacturer of aforesaid quartz mechanisms really do make good quality ones. And I haven't, touched wood, I'm not even going to say it actually, I never do, use one of them, because I was walking through the park like you do one day, thinking, hold on a minute, the gear ratio for the hour spindle is 60 times, it's about 1 to 1800. Now, even if the clock, the little motor inside, is quite weak, 1800 times more torque is quite a lot. Is that enough to actually get it to drive something? So after much experimenting, I thought, well, let's have a snail cam. Now, you can't see with this one. This was the first one that I made as a sort of trial to see whether it would actually feasibly work. Where's a snail cam? Hang on a minute before I fall over. It's in there. There we are. I won't go on about it too much because I have mentioned it in previous videos. So it's in there, and each 12 hours it slowly lifts up this follower, and that pushes the hand across, because as you know, I do like a timekeeping piece that doesn't go right round. So this worked, and then very briefly I thought, this is a gap in the middle, let's put something at AM PM. It has been nothing but a pain in the proverbial backside. Then there was another version. This bit worked okay, although with this version the problem was with the laser cut gears, there's always quite a lot of slack in them. It just can't be helped. So I realised early on I had to have some sort of weight, counterweight or some sort of spring, pulling this constantly towards 1 or 0 or whatever, to take up that slack, to keep it all accurate. And it did work really well. This was one where I had a lead weight on a gear on the back. And this was an effort to make it more simple. Yeah, okay, thanks very much. That one obviously didn't work too well because it didn't have that. Then I came up with this one. And this one did work fairly well. Everything worked with a little chain pulled down here with a little weight on it, which turned out to be a brass fishing weight in the end. That worked, except the AM PM indicator. What a pain trying to get it lined up. I did it all on the computer and the CAD and got it all lined up and calculated, but it kept jamming and not doing it right. But I did like the idea of having a little spirit level there. Red, look, red spirit level, red gem, possibly red gem in the end. So on to the next version, a version whatever it is, but dear friends, it works. I've had to fiddle around with it, as you can see, add some bits and pieces, but the AM PM has continued to work efficiently. I cannot tell you how thrilled I am about that. I also, with this version, realised that I've now got a 3D printer. I mentioned it before, but I keep forgetting. And that I could make all of the spindle parts out of 3D printed materials, right down to these spaces at the end. So I could include nice hexagonal looking bits on them. So that's exciting as well. So the stage we've got to now is I've spent the morning and some of the afternoon fiddling and farting about with this, trying to get all the details finely worked out. The AM PM, hang on a minute, where's the thing gone? Can't do more than one thing at once. Well, that's better. The AM PM sign was slightly too small, a different position with the lens, so I've adjusted that, made sure that there are actually the right number of divisions between each hour. Ho ho ho. This is the first bit I'm going to cut out. This is the 10mm piece that takes ages because it's so thick. But I'm really pleased. I think I've made lots of improvements to this. Also using grub screws in the end to tighten the gear shafts in rather than trying to push or glue or whatever. It just gives it more control. So that's the 10mm thing. I have set the power because I'm still seriously considering making this into a kit. So I thought, okay, I can have a kit and I can have a ready-made one. Why do the ready-made one first when I need to have the instructions and establish the best way to do it? So I'm working on that premise, hence the fact that there's no paint, which is going to be engraved on there. As always, I'm resting my 10mm thick acrylic on a piece of white card because I found any leftover laser power from when you cut 10mm, because it goes slow, goes straight through and tries to set fire to the machine underneath. The other great thing about cutting it on card is that it reflects some of the leftover beam upwards and it radiuses the edges on the bottom. Anywho, watching 10mm acrylic laser cut is rather boring, because I'm all fired up, whatever the expression is. This is going to be the time when I finally get the reciprocating chronometer into some sort of form as a kit. Definitely. Sort of. Well, maybe. It's only taken 5 years so far. Now, one other thing I noticed and remembered, some time ago, I think it was on Facebook and other places, I asked for people's suggestions whether they preferred the counterweight hanging down the middle like so, or whether they preferred it going off to one side over a little pulley and down here. And roughly the same, people said, but generally just came out for this version, erring on that version. And someone suggested, why not have that sitting in a glass tube with a gradiated scale on the front, and lovely. And I've just started working on this again, thinking, I know this one works. As with all my designs and inventions, I try and keep the cost as low as possible, and having another bearing and a glass tube. So I'm thinking I'm going to work on this one, get this version done, and then possibly, because there's not much difference, change this and add this as an alternative option. I did get as far as buying a lot of these lovely glass test tubes, which do sort of fit up the side. You can imagine that could look really nice. The base would have to be wider and other bits and pieces. It's possible. So I'm going to put that on the back burner, as we like to use management speak. But I'm not going to let it wither on the vine, and I'm still heading for Emerald City. Excellent. Now, on to the 3D parts. I just love it. Look at this. Incredible. Zoom in, move around. This is fantastic. And this bit of software, as I have regularly mentioned, expounded the joys of, is 3D Builder, which is free if you've got Windows 10 or something. Just do a search for it and you can download it from Microsoft. And it's brilliant. I need to export these as an STL file. Here's the slicer software, so I'm going to go File, Load Model, and it's all parts to print. Well, open. And then that displays them all here, and then it calculates how long it's going to take to print. That's what it's doing here, there we are, and how much filament it's going to take. It generally underestimates the time. 2 hours, 37 minutes, 4.76 meters, 14 grams. So now I save that as G-code and then go off to the 3D printer. It's all systems go, and I've got verbal diarrhea. I can't stop talking. The 10mm stuff has finished cutting it out. I think this is a two-hand job, so I will get back to you shortly. The moment of truth. Let's see. So far so good. Let's cut out beautifully. Lovely. This is, I so enjoy doing this sort of thing because as you can see, the feet that fit on the bottom are cut out of those two, which again means that the design is constrained, which I was whittering on about last time. It just makes you have to be so much more imaginative. Here we have the 2mm parts. Exciting! You get the idea. Let's see how the 3D printing's going. So that's the wheel, the AM/PM cam, which I suddenly realised I could print along with a shaft to mount the front bit on, sort of. It's just so brilliant. Voila, as they say in the trade. Not sure which trade. There we are, there's all the bits. That's that funny shaped AM/PM cam that goes on the front, and it's cut them all out beautifully tubs. Right, I'll get them put on the table. What I'm doing basically, whenever I've designed kits before, you get to the stage when you can do all the designing you want, so it's coming out of your ears. Then it is time to make all the bits up that you need and try for the umpteenth time to build one. And then once, if you manage to build it and you make notes and things, then you cut out all the bits again and you photograph the process as you go along, knowing with a fairly safe bet that it's going to work. The other really valuable part about making sort of working prototypes is to keep account of how much time and material you use, so you can actually cost what you're designing. No guesswork. Another little top tip, which took me, well, not surprising I suppose, a long time to realise, was I quite often, to save plastic, like I said, have bits cut out and then bits in the middle. And what I found was, when you have lots of different bits in the middle, I could never remember which bits I actually needed and which bits were just waste. If that's a problem for you, as it is for me, I realised that you just offset it. And then when you take it apart, it is absolutely obvious that that is not required. These two bits are. Thank you very much. Very briefly, because I've mentioned it several times before, the laser engraving. So the black is cutting the engraving laminates out. The green, which is the really fine steamhead.co.uk, is raster engraved. That's set up there, engrave. And then all the red, the rest of the engraving, it's so much quicker to do it by having lots of lines at much lower power. 0.1 millimeters apart. And it means that you can have it set much faster, much lower power, and it only has to travel and cut where you want it to, nowhere else, so it speeds up the process. It's the next day, and it finished printing, and I forgot to write down how long it took, because I'm keeping accurate records of such things. And as I said in the past, it took me 2 or 3 years to realise that this was actually a magnetic base. Instructions, you say. So here are the bits, and you can see how it's printed them. And this is a really good demonstration of the power. Let's take that off, and then you snap the base off, fire it across the room. This is the support that supports the hour. Here's one I made earlier. With laser cut acrylic, but it's quite a complicated thing. I've still got the gear cut out with the laser cutter because that looks nice and is very tough, but there's lots that goes into here. There's a little bit here that's smaller for the hour pointer, then there's a wider bit, then there's the hexagonal bit that's for the gear, then there's the little bit to put the chain on. There's even a 3D printed hole that goes through there that you can drop the chain into, drip a little bit of super glue inside, and it sticks the chain in. Fabulous. Then there's a bit on the front for that bit there, and then finally there's a little hole in the end for a gem to push in to hide the rivet. and the rivet sits down inside because it wasn't long enough to go right to the end. So it's all those things. It's a joy. I can do all that in one 3D print, especially the way of fixing the chain on it. It's one of those things, oh, just put a bit of chain around there, but when you actually come to think about it, it's really complicated and involved, whereas this is perfect. How very, very exciting. I've got all the bits made. I haven't counted them up yet. All the bits, but I've been keeping copious notes about how long everything takes and all the bits that I think I need. Having studied that one, the last one that I built, I've tried to work out how many screws and bolts and rivets and this and that and the other. So hopefully I've got it right, but that is why I am building it like this. Right down to the clock movement, everything. Those are those bits. Then I've put all the small bits in here with the lens, for example. The LED lens, which is there for the AM/PM bit. And all the 3D prints, the little bearings. Look at this small, where has it gone? Look at that. I'll have to zoom in. I've gone on about bearings before. The size of that, to think there's a load of little hardened steel balls rolling around inside that. That's incredibly small. That's the one that follows the Snellcom around. Snellcom. And then there's all the screws. Now I didn't have the right length of screw, so I've cut them down to make sure they are exactly as I've specified. I have ordered the right ones now, but I want to make sure from experience just having everything exactly as I think it should be. And I've even managed to AliExpress, managed to find the place that I got these from 5 or 6 years ago for this very job. Shows you how long this project's been going. So I've ordered 100 of them. Lovely. And what I've just done, well, I've planned all the machining that I need to do, right down to, especially with things like 3D printed parts. They're very accurate, but I need them exactly diameter 4.1mm heeled through the middle to allow the rivets to fit through accurately with very little slop. So I've drilled out them, countersink that, can't do that on the laser cutter. Tap that to M4, can't do that laser cutting. Tap that to M3, and then this is the big one. This is the ultra complicated one. Zoink, it's here. So it's the 10mm acrylic, and I think last time or sometime in history, I think it was when I built that last one, I realised it's much, much better or preferable to have tapped holes and little grub screws to hold the axles in, rather than pushing them in or gluing them in or whatever else. And all the other screws, I've tapped the holes, so there's a lot of machining to go on with here to do. Now my next job is to put it all together, so I think that's going to be for another video. That'll be for the next one, because I'm sure this is now running overly long. If you're still watching, thank you so much. Hope you found it interesting. Developing a new product is very, very exciting. If you've enjoyed it, please click subscribe and the bell and stuff, and hope to see you next time. Thanks again.